solving quadratics today using what is called difference of squares. Okay, let's talk about vocab. What operation does difference tell us to do?
Subtraction.
Subtract, yes. What about sum?
Addition.
Yeah. Okay, so you can see that this is being subtracted, right? And this one is being added. So what are squares? Well, what I mean by squares and what everybody means by squares is if you're talking about perfect squares. Okay, so when I take the square root of a perfect square, I should get like an integer type looking thing. Like x squared is a perfect square. When I take the square root of x squared, I just get x. Not like cube root of x or anything weird like that. I just get x. What do I get when I take the square root of 49?
7.
7. So do you see that these are two perfect squares?
Yeah.
Okay, perfect. So, what I want to do first is show you why. We're going to learn a little trick for factoring. Can you put your phone away? We're going to learn a little trick for factoring a difference of squares. But first we have to figure out why it works, okay? So, do you see that we're missing our bx term?
Yeah.
We have 0 x's, right? So let's write that in. So x squared plus 0x plus 49. Whoops, minus 49. Whoa. Okay, so what are the factors of negative 49 that sum to 0? Yeah. So my factored form would be x minus 7 times x plus 7. In the future, can that be done before class? Thank you. Okay, so let's talk about this really quick because I want to show you the trick. What happens if I do the square root of x squared?
You get
X, right? Isn't that what I have here
yes.
and here?
Yeah.
Okay, perfect. So what did you guys say the square root of 49 was?
7.
7. Isn't that what I have here and here?
Yeah.
Okay. Now the last thing that I want to show you, can you please put your phone away in your bag? Thank you. Okay, the last thing I want to show you is in the pattern is why we have to have a 1 negative sign and 1 plus sign. So if I do x times x, I get x squared. If I do x times 7, I get plus 7x. Negative 7 times x is negative 7x. And negative 7 times positive 7 is negative 49. What happens here and here?
They cancel.
They
and then we have
cancel.
our original.
Yeah, and then we get our original thing, which was the 0x, right? So the signs have to be opposite so that those middle terms cancel each other out. Okay, they've got to be opposite, otherwise they'll just combine to either positive 14x or negative 14x. Cool? Okay, so that is our trick. We take the square root of the first term and put that in the first spot in our binomials. We take the square root of the second term, that goes in the second spot, and then we have to have a minus and a plus, it doesn't matter what order, because we need the middle terms to cancel, and that's the pattern. Cool, 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 cool.
Mm-hmm.
Okay, let's look at this one over here. Let's do the same thing. Let's find x squared plus 0x plus 49. Let's find the factors of 49 that sum to 0. 7 and what? 7 and 7? So when I add them, what do I get?
You get 14, but you need to add put a negative seven.
Okay, so make one of them negative.
Then would that be negative 49?
So yeah, does that give me a positive 49?
No.
Okay. What if I make them both negative?
That'd be negative 14.
Oh, so that one doesn't work either?
No.
So if there aren't any magic numbers, then we say that this one is not factorable. Okay, so difference of squares, where we have perfect squares being subtracted from each other, they factor using this cute little pattern. Sum of squares, not factorable. Any of them. Cool? Okay. Let's look at some solving, and then we'll turn you loose on finding the pattern on your own. All right, so do you see that my first term is a perfect square? 16x squared is a perfect square. And so is 1 a perfect square. So I can factor this using my difference of squares rule. So I'll get my 0 ready, get my little parentheses ready. One of my signs has to be positive, the other one has to be negative. What is the square root of 16?
4.
And then what's the square root of x squared? X. So it should be 4x and 4x. What about the square root of 1? 1. Now I'm ready for the ZPP. How do you like that?
Easy peasy.
Easy peasy lemon squeezy. Okay, so I'm going to set each of them equal to 0. So 4x minus 1 is 0. And 4x, whoops, I should have one of them be plus. Did you guys make the same mistake I did?
No.
All right, well, that's good. All right, one of them should be minus, one of them should be plus. I thought I said one of them plus. Maybe the board ate it. Maybe I'm just need to go home and have a snow day. All right, so if I add 1 to both sides, then I get 4x equals 1. Divide by 4, I get 1/4. Subtract away 1, I get 4x equals minus 1. Divide by 4, I get negative 1/4. Put those in curly brackets. Okay, so we got two cute little solutions. So the parabola, this has a vertical stretch of 16, right? And it's shifted down 1 unit. That's why it's able to hit twice. See it? Thank you, Unit 5. Okay, let's remember from Unit 5 what happens here. Pretend that this was a y. Does the plus 81 shift it up, right, left, or down?
Right. Left.
Are we guessing?
Yeah.
Yes.
Yes. Down.
Yes.
Okay, on your calculator, I want you to put in the y equals x squared plus 1. Shifting up? Okay, yeah, but you guys also shouted out a lot of other garbage, like you didn't really know. Okay, so it shifted up 81 units. It's like way up here. Oh, I keep doing it lopsided. Okay, so this is the little y-intercept, 0, 81. Does that have any solutions, real solutions? No. Okay, so let's remind ourselves what happens when we try to solve this. All right, can we use the square root method on this one? Get the x squared part alone. So then we'll have x squared equals negative 81. And let's do square root, plus minus. What happens when we have a negative under the radical? All right, ask your calculator what the square root of negative 81 is.
She's gonna say error.
I'll do it too. Oh, my calculator is not ready. Darn it.
Shaped.
Yeah, error, non-real answer. So are there any real solutions to that equation?
No.
Here, I'm going to show the video really quick. So if I do the square root, whoops, that's not it. Square root of negative 81, I get an error that says non-real answers because there aren't any real solutions. So when you have a negative under your radical, you get no real solutions, which agrees with our Unit 5 picture that we barely managed to recall. Okay, cool. So when we do this bottom part, I want you to remember if we have a difference of squares, you can factor using the fun little pattern. If we have a sum of squares, don't even try. It's just not factorable. All right, I want you to try the bottom. This. Okay, you're going to get your little binomials ready in parentheses. Pick one to be positive, one to be negative, and do square root, and put everything where it goes. Go. Okay, so kids in class had to figure this out on their own. I made them do it, but I'll go through it with you guys because you don't have your classmates to talk to about it. So we're going to use the pattern. We see that x squared and 36 are both perfect squares, so we get our little binomials ready to go. We know one has to have a plus and one has to have a minus, so if we FOIL them back together, the middle terms cancel. Then we do square root of x squared, that's x. Square root of 36, 6. And that's this one. Boop. I can even check it. Look, x times x, x squared. X times negative 6, negative 6x. 6 times x, positive 6x. 6 times negative 6, negative 36. Cancel, cancel. It matches my original problem. Okay, now that we trust the pattern works, let's do some more. Get your parentheses ready. One positive, one negative. Square root of 121x squared is 11x. Square root of 4 is 2. Here. Boop. Okay. Get my parentheses ready. Square root of 20, plus minus square root of 25x squared is 5x. 5x. Square root of 9 is 3. Okay. Okay, now that we've done a few together, I want you to try to do the rest. I'm going to do them, and then you can check your work with me. So pause the video, do them, and then see if you get what I got. Okay, I already messed up. I was like so excited to be on a roll, and I fell for my own trick. You guys see this right here? That is a plus. Okay, so that is not a difference of squares that is factorable using our little trick. Okay, that is a sum, and it's not factorable. So I have to go back, walk of shame, okay, and I have to write not factorable on this one. I can't believe I just did that. So I hope wherever you are, you're laughing at me. Okay, notice that f is also a sum of squares, so this one is also not factorable. That's how I caught myself because I was like, wait a minute. Okay, let's just finish these together if you haven't already. So this should be 8x minus 3 times 8x plus 3. Oops. 10x plus 2 times 10x minus 2. And last but not least, 5x minus 7 times 5x plus 7. Okay, that's it. All right, here we go. Let's look at the back. Woo! All right, these are some problems that we have to factor. So for A, I see that they are both perfect squares and they're being subtracted. So I can get my parentheses ready. I know it's going to be a plus and a minus. I can do square root, and I get 5x plus 4 and 5x minus 4. And I'm done. All right, for B, I'm factoring, right, still, and I have a GCF. So I have to first factor out my 4, and then I get x squared minus 9. 36 divided by 4 is 9. Inside my parentheses for my leftovers, I have a difference of squares. So I keep my 4, get my parentheses ready, pick my plus and my minus. Square root of x squared is x. Square root of 9 is 3. And now I'm done. Okay. C is another trick, like the one I fell for on the front. It's got a plus. This is a sum of squares, and sum of squares is not factorable. Oh, D is a beast. All right, you ready for D? You guys are gonna love this. All right, so if I take the square root of x to the 4th, when I get my little parentheses ready, it gives me x squared. Right? Think about it. Doesn't x squared times x squared, oops, give us x to the 4th? Yeah. So that's what goes there, and then my plus and my minus, and the square root of 81 is 9. Now you'd think, oh, I'm done. But look at this binomial. That is still a difference of squares. This one's a sum. This one's a difference. So the sum doesn't go anywhere. I can't factor that one anymore. But the difference of the perfect squares, I have to keep factoring. So I'm going to keep my x squared plus 9, keep it. And then this one, I have to get my parentheses ready again. Do my plus and minus. Square root of x squared is x. Square root of 9 is 3. Okay, now it's factored completely. I told you guys would be good. I like that one. All right, I'm looking at this quadratic. I see right off the bat that 3 and 27 are divisible by 3, so I'm going to divide both sides of my equation by 3. So I get x squared minus 9 equals 0. Now, we used to do this by square root method, where we would get x squared equals 9. Take the square root, plus minus, and we would get x equals negative 3 and positive 3. But now there's another way that we can go. We can see, oh, I've got a difference of squares. So I get my little parentheses ready, and I get square root of x squared is x. plus minus square root of 9 is 3. And now I can use my ZPP. So I've got x plus 3 equals 0, x minus 3 equals 0. Now I can see that x is negative 3 and positive 3, just like what I got when I did square root method. Let's do B and then we'll be done. I don't want this to be the longest video ever. Okay, so for B, notice that we have a GCF. We can factor out a 5x. So here's my 5x. Here's my x. Whoops. 10x squared divided by 5x is 2x. And 5x divided by 5x, that's minus 1. Okay, now I can set each of my factors equal to 0. And solve. So this x is 0, and this x is positive 1/2. And that goes in curly brackets. 0 and 1/2. Okay, ta-da!